From the Institute of Hydraulic Engineering and Water Resources Management, Aachen University, Germany, and he will speak together with George Johann. Please.
Yes, that's me. Good evening, ladies and gentlemen. I'm coming from Emscher Genossenschaft and Klippeverband, and we are talking about the integration of geotechnical dike reliability into our operational flood management system of Emscher Genossenschaft and Klippeverband, and we are doing this via fragility curves with generated Daniel Bachmann, and he's talking about that in a few minutes. So, Emscher Genossenschaft and Klippeverband are two tributaries of the Rhine before the Rhine goes into the Netherlands. Especially the Emscher is very dense populated, as you can see here easily. And if you don't know these catchments right now, I give you a link. So if you watch soccer this evening or any time you have ever to think about our dikes and our catchment, I promise you. So, and that's not only soccer, it's especially coal mining, which has a consequence of subsidences of the surface up to 25 meters in our catchment. And that's why the people are living there, like in the Netherlands, under the water level, as you can see here easily. And we have, as you saw, 200 kilometers dikes. The highest dike is 70 meters high. I think it's the highest dike in Europe at the river, not at the sea. And this is the annuality of our dikes. So it's somehow a complex system, and to manage such a high-risk catchment we have some tools. And one tool is our dike data service, and there we get every data we can get into this service, and just to do some risk assessment before an event occurs and while the event to support personal deployment. And this is an example how it looks like. So now we go for an example to Gelsenkirchen, where Schalke plays soccer, and you see, well, here right now, the yellow transparent things are the floodplains, the potential floodplains, and the freeboard is highlighted green or yellow. And if you get some further information, okay, here you have the legend also. Oops, this was the wrong thing. Here you see up to 1 meter is yellow and green is 1 meter freeboard, and also you can get information every 100 meters of water level, dike height, etc., etc. So this is offline, and then we have online for the event management 40 gauges which come in every 15 minutes to highlight also the overtopping risk, overflowing risk of our dikes. And we do also discharge simulations forecasts. This is the present situation, and the forecast also we do for 6 hours and 24 hours. So for the calculated, we calculate every 5 minute steps. So this is the overtopping risk. Now we are thinking about what about the geotechnical availability, reliability, and that's where Daniel Bachmann comes in and shows you how we realized it. Thank you.
Thank you, Georg. Yes, now the question was how we integrate the geotechnical aspects into the analysis or into the dike data system at the Emscher Genossenschaft. The idea is very simple. We use already existing data from the Emscher Genossenschaft, transfer it in our system into a very simple output, which we can again put into the dike data system of the Emscher Genossenschaft. And so we get the geotechnical aspects also into the operational flood management system. Okay, we use for the transformation our tool Probabilistic. Probabilistic is for the risk-based evaluation of the flood protection, of the existing flood protection and of flood mitigation measures. And it was developed, or is developed, at our institute since 2006. It's modular design software package, completely written in C++, and it provides models for the risk analysis here, but also for the base analysis, for the reliability analysis, hydrodynamic analysis, and the analysis of consequences. The analysis are combined or individual applicable. In this study, we just use the reliability analysis. At the outcome of the study, we get the fragility curve. The fragility curve summarizes the existing geotechnical and geometrical data into one curve. Here you can see the stress to the dike section, and with the curve we can, when we know the water level, we can determine very quickly the probability of failure conditional to the water level. In this case, for 2.30 meters, we get a failure probability of 0.75. How we calculated the fragility curve? There are three different ways. There are statistical analysis. In case for dike failure, it's very difficult to get the data set. So you have two other possibilities, for example, a model-based probabilistic analysis. This we use in this study, or you have also the expert judgment. We use the model-based probabilistic analysis. Therefore, we have a fault tree analysis for a general dike, and we use a Monte Carlo analysis then to integrate the variability of the parameters. At the end, we don't calculate a continuous fragility curve. We calculate discrete points of the fragility curve where the water level stays deterministic and the other parameters are model probabilistic, and then we get a point of the fragility curve. Here the model of the structure type. Which failure mechanism do we include? We include at the one side the hydraulic failure mechanism. We just include or taking into account for this study the overflow mechanism. The overtopping mechanism is not very important for the EMSHA because of the fetch length. We also have hydraulic failure mechanism. It's a heave event in combination with the piping event. To model the piping event, we used three different approaches: the Lane approach, the Sellmeier approach, and the Schmertmann approach. And we also have static failure mechanisms, the macro and micro stability at the landward and the water side. And therefore we use a slice-based model after Cray. Here's an area under investigation. Again, it's in the western part of Germany, and we look here for the lower reach of the EMSHA near the Rhine River. What we get from the EMSHA Genossenschaft are data about the cross-section of the dikes. We have the geometry of the cubature and the material zones, and we also get the mean values of the material parameters, for example, for the porosity or the density. For the statistical moments, like the standard deviation, we make a literature research, and we get also from the EMSHA Genossenschaft the extent of the quasi-homogeneous characteristics. So we come from a cross-section or from a profile, we can make a section out of the profile. With this data, we make the model set up for 33 dike sections, which we calculate then in the Prometheus package. Here you can see the calculation. Here is still on the way to calculate the fragility curve for each water level, and here you can see the 33 dike sections. At the result, here an example, it's the first dike section near the River Rhine. It's a total fragility curve, and in this case the Sellmeier approach for the piping mechanism is included. We recommend to use the Sellmeier approach because in 90% of all dike sections in our study, the Sellmeier fragility curves lay between the Schmertmann fragility curve and the Lane fragility curve. And here you can see the crest height. There is still remaining resistance, but it was, or the assumption was that the dike normally will fail when it's overflown. The second results, you get the partial fragility curve, where the different failure mechanism, the probability of the different failure mechanism are shown. In this case, for this dike, the piping failure mechanism is the most important failure mechanism. You can see it here at the probability. If you add this point, and for example this point, then you get the total fragility curve. This information is also important to get information what is the weak link in my dike section. Okay, we calculate the fragility curve per dike section. We get this data again back to the Emscher Genossenschaft, which implement the data into the dike data service. And the idea is now we get current or predicted water level, and we do not just compare the current freeboard. We also get geotechnical aspects into the operational assessment. We have the water level per section, and if we take the water level into the fragility curve, we get failure probabilities, which we can, for example, divide it into different groups with different colors, and then we can maybe trigger some countermeasure from the Emscher Genossenschaft. As a short summary, we try to show us the current application of the dike data service, which is based on the freeboard. We try to integrate also geotechnical aspects of the dike reliability into the operational flood management system with the fragility curve. The calculation of the fragility curve we have done by the Prometheus software package, and we use it for 33 dike sections. What we will do further, now at the Emscher Genossenschaft there will be a plausibility check of the fragility curve with the expert there, and the information will be integrated. There must be tests and evaluation of the extended system by real flood events, because there it's the probability when I trigger a measure at the right time point, not too soon and not too late. And we will calculate further dike section to get in the upper part to get a complete database for the Emscher dikes. Thank you for your attention.
Thank you both of you for the presentation, which is very comprehensive. Maybe we will need a little bit more time to be in, because it is a little bit more complicated. Maybe I can ask the question, what is acceptable probability of failure divided by high of the water, in which you will start with some action?
I think question to the decision
that's a question we are thinking about, since these results are in our house. So we are talking about right now about relative risk. So we see dikes which are relatively high, with a high risk and with a slow risk. So if you can make games and say, okay, now the water level rises, which dike section will be first be highlighted? And this is for the development, also the supply of the personal deployment, which also have experts there at the dike and say, okay, first we go there, and then second we go there.
So with the help of this curve, you can define the priority of this. Yeah. Please. Okay.
My name is Vorogushin from German Research Center for Geosciences. Does your model for computation of the fragility curve consider the time dependency of the flow hydrograph, so the impoundment duration, which actually affects the probability of failure?
No, it was stationary.
Another question? No. Therefore, thank you very much once more.